Classification of organic compounds. Organic compounds can be classified in many different ways. Here we are going to classify organic compounds based on the arrangement of carbon atoms in their structure. Based on this, they can be classified under two different heads. One is the acyclic compounds and the other one is the cyclic compounds. The acyclic compounds are also called as aliphatic or open chain compounds because they don't have a ring structure, whereas the cyclic compounds can also be called as closed chain or ring compounds. The acyclic compounds can be further divided under two different heads. One is the straight chain compounds and the other one is the branch chain compounds. In straight chain compounds, all of the carbon atoms are going to be in a straight chain. So say for example, let's take the structure of butane. Butane has 4 carbons, but all of these carbons are going to be in the same row. Here is the structure of butane. So you can see that all of these carbons are exactly in the same row, same straight chain. But in the branch chain compounds, you will see one or more carbons existing as a branch. Here is an example for a branch chain structure where you can see that this CH3 group is coming off from this straight chain. So here the straight chain has got only 3 carbons and this carbon is coming off from the straight chain. So these are called as branch chain structures because we do have a branch coming off from the straight chain. When it comes to cyclic structures, they can be further divided under two different categories. One is homocyclic and the other one is heterocyclic. In the homocyclic compounds, you will only find carbon in the ring structure. So this is going to have only carbons in the ring structure and therefore they are also called as carbocyclic compounds. Whereas in the heterocyclic compounds, you're going to have other atoms also. Say for example, you can have oxygen, you can have nitrogen or sulfur. Because you have atoms other than carbon, this is called as hetero. When you say hetero, it's going to be different. The homocyclic compounds can be further divided under two different categories. One is alicyclic compounds and the other one is aromatic compounds. Here are some examples for alicyclic compounds. Cyclopropane, which is generally represented as a triangle, is an example for an alicyclic compound, where you can see at the intersection of each of these bonds, you will see a CH2 group, and a CH2 group. So this is the actual structure of cyclopropane, where you can see that it is the carbon atoms that is forming the ring structure. Right? One more example, cyclohexane is an example for an alicyclic compound where you can see that it is that at the intersection of each of these bonds you will be seeing CH2 group. And it is only the carbons that is forming the ring structure and therefore they fall under the category of homocyclic compounds. And you can also have one or more double bonds, but keep in mind that this shouldn't form an aromatic structure. Let's go on to the next set of compounds, aromatic compounds. The Greek word aroma means fragrance. So these compounds are going to have some sort of smell associated with it. These aromatic compounds are generally cyclic and they're going to have unsaturation in it, meaning that it's going to definitely have double bonds. And they can be classified under two different heads. One is benzenoid compounds, another one is non-benzenoid compounds. In the benzenoid compounds, you will have benzene as the structure. So here is the structure of benzene. Benzene can be represented like this or like this. Anytime you have this structure right here in your compound, it's called as benzenoid compounds. Here are some examples for benzenoid compounds. So let's say that you have a methyl group on this benzene structure. Then it's called as toluene. When you have an NH2 group on this benzene molecule, then it's called as the aniline. Okay? So here are some examples. Non-benzenoid compounds are also aromatic compounds, but they do not have the benzene structure. Here are some examples for non-benzenoid compounds. Now let's take a look into these two compounds and see whether it has got a benzene structure. Yes, it has got 3 double bonds, such as what we see in the case of benzene within the ring structure, but the number of carbons here are different. Take a look into this. This has got totally 7 carbons. When you say benzene, it is definitely going to have 6 carbons and it is going to have alternate double and single bonds. So here is the structure of benzene, but these structures doesn't have benzene ring structure and therefore these fall under the category of non-benzenoid compounds. So anytime you do not have a benzene ring structure and still they are going to be aromatic, then it's going to fall under the category of non-benzenoid compounds. So on the whole, the homocyclic compounds are going to have only carbons within the ring structure. Right? In all of these cases we have seen they only have carbons. So even here they only have carbons. Here you might think that there is an oxygen, but this is not part of the ring structure, right? When it comes to heterocyclic compounds, here are some examples. Pyrrole is an example for heterocyclic compounds where you can see that yes, this is a 5-membered ring structure, which means there are 5 atoms in the ring structure. Carbon, 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 and here we do have nitrogen. So take a look into the difference between these compounds, homocyclic compounds and heterocyclic compounds. Here we only had carbons, right? But here we also have nitrogen within the ring structure. Here's one more example. This is pyridine, where you can see that there are totally 6 atoms in the ring structure, and out of this, one of the atoms is nitrogen. Okay? So therefore, this falls under the category of heterocyclic compounds. Remember, the heterocyclic compounds can also be classified as aromatic and non-aromatic compounds. Here are some examples for aromatic compounds. Whereas when you have compounds like these, then it's going to fall under the category of non-aromatic heterocyclic compounds. So on the whole, when you say homocyclic compounds, it's going to have only carbons in the ring structure. Whereas when you say heterocyclic compounds, these are going to have atoms other than carbon in the ring structure.